Good morning, everyone. This is Jennifer Hammer. I'd like to welcome you to our July 9th membership meeting for the Lower Des Plaines Watershed Group. We have a couple of just housekeeping things before we get started with our presentation. So the first thing we will do will be to approve our May 14th, 2020 meeting notes. And I guess through the presentation today, if you have questions, please enter them into the question box, and I will keep track of those. And then we'll have John answer any questions kind of at the end of his presentation. And then when we go through our polls, really the only one we have for an approval today is the minutes. So I think we can move right into that. If I can get someone to raise their hand to make a motion to approve the minutes from the May 14th meeting. Okay, I have Scott Killinger and seconded by Felicia Hurley. I'm gonna launch our poll. So if you can just click the aye, the nay, or abstain, and then hit your submit button. Okay, thank you. So we are going to jump right into our presentation. I'd like to introduce John Scott from the Illinois Sustainable Technology Center at U of I. I'm gonna stop sharing my screen and he's gonna share his and present from his computer. So John, if you wanna go ahead and share your screen.
How's that look?
Yep, perfect.
Okay, thank you for the introduction and thank you for having me today. So I just wanted to kind of give you guys a quick breakdown of the background of these compounds, these perfluoroalkylated substances, and then give you kind of a taste of some of the research that's going on at the University of Illinois at the Illinois Sustainable Technology Center. So perfluoroalkylated substances, or PFASs, are basically just man-made compounds. There's no natural sources of these compounds that I am aware of. And what makes these compounds so special is the carbon-fluorine bonds. And here on the left, upper left, is a typical structure for a PFAS. It's perfluorooctanoic acid, or PFOA. And what makes this compound so unique is that fluorocarbon tail is hydrophobic and oil repellent, while at the same time, this hydrophilic head is water soluble. So what we end up with is a compound that is basically oil and water resistant, but at the same time is water soluble. So this is quite unique than most of the stuff that we've encountered in the past. And the other real noteworthy point of these compounds is the strength of these carbon-fluorine bonds. These are some of the strongest bonds known to organic chemists. And it's what makes these compounds so darn stable. So what we end up with is this oil water resistant compound that is water soluble. And that's what makes these things so useful, but at the same time, it makes them so problematic. So they're very unique and interesting compounds. So, you know, typically we hear about PFOA and PFOS, and these are the most referenced PFASs. However, in reality, there's more than 4,000 of these compounds known. And, you know, to achieve the desired properties that we want, we can do things like vary the chain length of the height of the tail. We can make the compound linear versus branched. We can vary the degree of fluorine saturation by removing the fluorines and putting the hydrogen. And we can even change the functional group at the head of the compound, like in the case with PFO and PFOS, or PFOA and PFOS. So we can really vary these things to get the properties we want. Another one we hear a lot about is this Gen X compound. This is what we call the next generation perfluoroalkylated substance. And it's basically just we replace one of the carbons with an oxygen. And the other thing we can do is polymerize the smaller PFASs to make a larger macromolecule like Teflon, so on. So my point is that, you know, even of the thousands of them that are known, there's also, you know, these things will change in the environment and even in our bodies. So there's unknown PFAS out there, and it seems like people are finding new ones every day. So the point is given all the different possibilities out there, this alone makes the analysis, the treatment, and even the regulation of these compounds extremely difficult. So given the properties, it's no surprise that these things find their way in a wide range of products and materials. Some of the most common uses are your aqueous firefighting foams, your textiles, your plastics manufacturing, your metal coatings, your paints, your additives for oil extraction and mining, and even in our food packaging. And the things, the uses that I really am concerned about, for starters, is aqueous film firefighting foams. And it's because we use these things in large quantities and we directly spray them in the environment, and they typically just run off and get in our soils and our waters and our sediments. So this here is a big concern for me. And the other thing too is I really worry about the firefighters that are exposed to these materials, because firefighters got an increasingly high rate of cancer. And I often wonder if PFASs contribute to these high cancer rates in this population. So it's definitely a concern of mine. The other thing I'm very concerned about is food packaging, because here we have, you know, when we coat our food packages with these materials, we have the potential for human exposure. And the thing that I find very ironic about this is a lot of these materials that we're coating with PFASs are intended for single use. So now you have something you're coating with a material that's going to last forever, yet it's only going to be used once and thrown away. So I think that's a crazy application. And then lastly, you know, I'm very concerned about, you know, these things in textiles, because, you know, a lot of textiles have them for stain resistance, and, you know, we're always in contact with a lot of these textiles. You can imagine wearing a piece of clothing that has PFASs in it, or maybe sitting on a chair that's coated with PFASs, and over time you can potentially absorb these compounds through your skin, and there's a potential route for dermal exposure. So those are the three main uses that I'm very focused on. So let's look at the occurrence of these things, and water is a logical place to start. And, you know, surface waters, groundwaters, and drinking waters have been intensely studied, and presence of these things have been well documented. In fact, back in 2016, some researchers surveyed all the US EPA data for PFASs, and they found that 194 out of about 4,900 public water supplies had detectable concentrations of PFASs. What really got people's attention is that they estimated that about 6 million residents had access to water that was above the health advisory limit of 70 nanograms per liter, parts per trillion. So this really got people's attention. Now, just a couple other studies I pulled from the literature. Back in 2019, another group looked at all the groundwater and surface water data, and they found that, you know, PFAS commonly found in surface waters and groundwaters. They did find sites all the way up to 11,000 and 64,000 parts per trillion. Now, granted, these were at locations near where training activities took place, firefighter training activities, or even, you know, industrial dumping. But these really high levels are out there, and they also have the potential, you know, to get into drinking water. And then the one that I really focused on, it caught my attention, was a 2019 study that looked at the source and treated drinking waters in the United States, and they looked at 50 facilities, and they found PFASs in all of them, all the way down to a part per trillion and all the way up to 1 part per billion. And the thing that caught my attention is they determined that the median source in the treated water was actually very similar. So what this means is that our drinking water facilities are ineffective at removing PFASs. They're not designed to handle these very bizarre and unique compounds. So that's really what I focus on. So, you know, water, in addition to water, there's a lot of studies about soils and sediments. And certainly this media is a good sink for these compounds, especially those that are near, you know, training facility sites and where things have been dumped over the years. And then there's also, places where biosolids has been dumped. We know that these soils or sediments in these areas are usually really high in these compounds. But beyond waters and soils, these things are just pretty much everywhere we look. Even our wildlife, our plant tissues. I became aware of these compounds about 10 years ago when I saw a report about polar bears. Now, polar bears, about 10 years ago, that people are finding that they seem to really accumulate PFAS. And what I find quite remarkable is that these man-made compounds are actually finding their way into pristine environments such as the Arctic poles. So another thing that, another media that I'm interested in is indoor air. These things are turning up, all around us in our indoor air, and it's not surprising because we're surrounding ourselves with textiles that are coated with these materials, and then they actually end up in the indoor air that we breathe. Last year, the FDA looked at 91 samples, food products, and they found that 14 of them tested positive for PFASs. However, from the results, they weren't sure if it came from the food itself or the packaging. But still, there's another potential route of exposure: consumption of food, ingestion. It's kind of concerning. So the bottom line is these things are just about everywhere we look, and the term ubiquitous applies here. So how do they get into the environment? And there's a lot of potential sources for them to get there. But the five, in my opinion, these are the five main sources. And, there's a lot of documentation of illegal dumping. In fact, my colleagues in Michigan have sent me photos of drums of tannery waste that were illegally dumped and had gotten into the groundwater. And then obviously firefighting foam sites where they're training, there's runoff. Those places typically have very high concentrations. Now, wastewater effluent is another known source, and it's no surprise given that these facilities receive large volumes of industrial and residential wastewater, and they're really not designed to treat this class of compounds. And this would be a logical place to treat for PFASs. However, having said that, we have to be very careful because we have to find a way to do it in a very cost-effective manner. Municipalities are already stretched so thin with resources, and they're dealing with such large amounts of water in a short amount of time. So it might, if we're going to treat PFASs here, we have to be careful. And in my opinion, these guys are really the true environmentalists. And in fact, next time you see one of them, you should give them a hug. Just be sure to do it 6 feet away. Now, the sources of PFASs I am very interested in is landfill leachates and biosolids from wastewater treatment plants. Now, if you think about all the textiles, food packaging, all the PFAS-laden materials that must show up at the landfill every day, and it's no surprise that landfill leachate is known to have high concentrations of these things. Now, biosolids is the leftover solid material for wastewater treatment. And it's also known to have high levels of PFASs. And, the fate of this stuff is either to be land applied, since it's a great source of nutrients, or it ends up in a landfill. So I believe that, here in the Midwest, land application is common. And I believe we really need to get a handle on how these PFASs move from biosolids to soil, to plants, to groundwaters and surface waters, because when you apply them to land, they really have the potential to become mobile and even translocate into agricultural crops. So I really, some of the projects that we are trying to get started is to look at how these things, move through biosolids into the environment. And we really need to provide the wastewater treatment plant operators with some level of guidance of how much is an acceptable level in their biosolids, because I know for a fact that that's something that they really need because they've asked me for it. So the other thing about the biosolids, so now if we don't apply them to the land, then the next choice is to throw them in a landfill. And then, like I said, landfill leach is known to have high PFAS. So you can imagine the situation. In landfill leachate is often sent to the wastewater treatment plant. So you can imagine the situation where you go from biosolids to landfill leachate back to biosolids, and then the cycle continues and we're never really treating it. We're just moving it back and forth, all the while concentrating it. So it's definitely an interesting problem, and it's something that we are trying to research at the center. So now that I've kind of talked about the occurrence of these things, let's see how they occur in humans. And back in 2017, the CDC researchers found that 97% of people surveyed had one or more PFAS in their blood. And a French study that I found did find that breast milk was typically lower than serum. However, they too had a pretty high detection rate, 82%. Now here on the right is the results of a study that looked at the mean concentration of PFASs in human blood. And you can see United States, we have to be number one. And yes, we're number one in this area as well. Over 30 parts per or nanograms per mil of a medium concentration. Now, the thing that I find very interesting about this is if you look at our friendly neighbors in Canada, they're actually greater than a third less in medium concentration. So I really wonder why that is and what can we learn from them, from our neighbors. So this is really kind of an interesting set of data that I just wanted to share with you. So now that we know they're everywhere and we know they're even in our bodies, the question is, well, should we be worried? And in the world of emerging contaminants, we really ask ourselves three things. Number one, is it persistent? Number two, is it bioaccumulative? And number three, is it toxic? So let's start with persistent. And with the case of PFASs, I couldn't think of a more persistent organic compound out there. Now, obviously, metals stick around longer, like lead and arsenic, but really, I think when it comes to organic chemicals, PFASs are designed to be very stable. And that is the reason they do not go away. They do not readily break down. In fact, even groundwaters on select Air Force bases, even after 7 to 10 years, they're still finding 7,000 parts per million PFASs in the groundwater. I mean, that's approaching percent level. I mean, we can almost pump the stuff out and use it as a firefighting foam. So it's just, they incredibly linger in the environment. And even in our bodies, it's estimated that, these compounds can stick around for, 4.8 to 3.5 years. A very long time. So I think, and this is why we call them forever chemicals. So I think it's safe to say persistent is a problem. Now, for bioaccumulation, our friend the polar bear has shown that these compounds do readily bioaccumulate. In fact, there's laboratory studies from water to fish that have shown that, these critters can, soak up 690 to 4,000 times the background concentration of PFASs. And typically the longer chain ones accumulate greater. If we change that functional head of the PFAS, it can also change how it bioaccumulates. But overall, we can say yes, it is known to be very bioaccumulative. And the last one is toxic. And there is a lot of animal studies actually out there that have shown that PFOA and PFOS, the model PFASs, induce immune and liver damage, neurobehavioral toxicity, birth defects, delayed development, and even tumors. But the point here is a lot of times, you feed a rat a pound of anything and it's going to get cancer. So they really need to look at what level these things induce these effects. Because the things that we find in the environment are quite low, usually part per trillion, unless in isolated cases. But my point is we really need to get a handle on what environmental exposure, will cause these toxic effects. And there is some epidemiological evidence that it can cause kidney and testicular cancer, decreased birth weight, thyroid disease, decreased sperm quality, high cholesterol, and diabetes. Diabetes is a really convincing one. It's very interesting if you look at the data that there's some good correlations with PFASs and diabetes. So just to kind of rehash, we know that there's exposure to these things. We know they're persistent. We know they're bioaccumulative. The toxic, people are still looking at that, at, what level. My feeling right now, it's a probably. It'll probably turn into a yes. But the point is that I think there's cause for concern for these compounds. So what are we going to do about it? And in pollution prevention, there's a hierarchy. And really the place you want to be is up top, and it's the reduce, the reuse. The reduce the use of it. And, for me, I would focus on one of the things, the easy things to get is to eliminate these things from our single-use materials. Because like I said, most of the stuff is filling our landfills and then getting into the environment. So this would be a logical place to start, but it's hard because you have to cause behavior change and, move people away from choosing things that contain these materials. And obviously replacements is another thing, but that's a very difficult thing to find right now, to find replacements for PFASs because they're just so unique. Obviously regulation is another option. Many states, the regulation is very interesting that on the federal level, there's really no movement that I'm aware of in the area of PFASs, but individual states have actually taken the initiative to start developing their own guidelines and standards for regulating these compounds. But here again, we have to be careful. I think it's New Jersey that wants to regulate these compounds down to 13 or 15 parts per trillion. That's a really, really low concentration. And that is really going to be hard for drinking water facilities and wastewater treatment plants to really get down that low. And it's just crazy. And I don't know how they're going to do it. And it'll be interesting to see, but it's really going to be a burden on our municipalities who are already stretched so thin. And in fact, in Illinois, last year we had a bill moved to the state house to amend the Safe Drinking Water Act. And now they want to, as part of this legislation, they want to charge the Illinois Department of Public Health to establish, maximum contamination levels for PFOS, PFOA, and some other PFASs. But, poor public health, I hope to God that they're giving them more resources because, these guys too are stretched thin. And even with the current crisis going on, I'm sure they're stretched even thinner, and PFASs are probably not as important as everything else that's going on. So I'm really worried about public health. But anyhow, Illinois EPA is proposing to change sections to the 6020.410 groundwater quality standards. And they want to add 5 PFASs to the contaminant list and provide standards. But here again, remember I told you earlier, there's thousands of these compounds. And these are common ones, but maybe we need to start thinking about the other PFASs that are out there as well. So at ISTC, most of my work is in the analysis of these compounds. I'm very interested in developing methods to. One of my major focuses is to try to find a way to screen for PFASs. I believe that this is a need for the community and is something that I'm very interested in working very hard in, but I also get involved in the fate and transport. Now, Wei Zhang, my colleague, he is a big fate and transport guy. He's really into the biosolid plant-soil interactions, groundwater, how it gets in the groundwater, but he's also working on designer bio-based sorbents for these materials. And he's even done some interesting things of thermal treatment of biosolids because, like I said, they're a major source of these compounds. And then also Jamin Kim, he's a colleague of mine, a material science guy at ISTC, and he's working on novel sorbents. Activated carbon is about the most common and employed sorbent for these compounds. However, it's limited in how many times you can use it. And also when you're done with it, what do you do with it? You have to landfill it, and then it adds to the landfill problem. But so he's working with things like clays and cheaper materials and materials that can be reused. And he's also interested in trying to destroy these compounds because even after absorption, you're going to have to find good way to break it down once it's been absorbed. So these are some of the major activities in this area at our facility. Now, a lot of my work is in the area of microplastics. So if you guys are ever interested in microplastics, I'd be more than willing to come back and give you a talk on that. And I can talk for hours about microplastics. But they are also another persistent pollutant that is ubiquitous. And I'm interested in how these things absorb contaminants from the environment. So last year I completed a study on Lake Muskegon where I took microplastics and I put them in the lake, and I would come back and I would pull them out at different times and look at what was absorbed to them. And PFAS was one of the class of the compounds that I was looking at. And I did find indeed that these things were concentrating background PFASs, hundreds of times greater than what was in the water. So as the result of this, something can come along like a fish and eat this plastic. And not only is it getting exploded as plastic, but also everything that's associated with it. And the really interesting thing about the PFASs and plastics is that if we take plastic in the laboratory and we expose it to PFAS, we don't see that degree of absorption, maybe 20, 30%. But when we do it in the environment, it really skyrockets. And what we believe is going on is the microplastics will get a biofilm on them, like a consortium of biological material from the environment. They're like a substrate for it. And we think that the PFASs are actually associating with the biofilm and not the plastic itself. So that is a kind of a secondary absorption effect. Something interesting that we found, and I'm getting ready to write this up as a paper. So for the analysis of PFAS, the standard method right now is a liquid chromatography mass spec, tandem mass spec. And the technique is extremely sensitive. But and it also measures individual PFASs. But this is also a problem because you only measure the PFASs that you're looking for. So here are just some of the standard methods. This is very labor intensive. It requires expensive equipment. The quotes in the past that I got were $500, $800 a sample. And so please don't call me and ask me to analyze your samples for PFASs. That's something that I don't do. We only do it to support our internal research. But yeah, so this is the thing I want to address. So I think it's crazy to try to analyze all the individual PFASs. So what I'm interested in is maybe we can screen samples for total organic fluorine. And there are some methods out there already. There's this total oxidizable precursor assay. And here a lab will convert all the PFASs to two main forms, and then they still have to use an LCMS, but then they just look for these two forms. Now there is some of these PFASs that are not oxidized and not accounted for, and you still have to use sophisticated equipment. It still can be quite expensive. There is other techniques where the sample is combusted, and then they look at the fluoride left over. It has a hard time telling the difference between inorganic fluorine and organic fluorine. If you do that, you have to run it twice, so still quite costly, quite labor intensive. There is another technique called particle-induced gamma emission. It's pretty much used in academia. It does measure directly in a solid sample, but the accelerator, and not all of us have one of those laying around. In fact, Graham Peasley, I believe, is the guy that's doing a lot of this work. He's got it when he drives around, but it's just kind of a specialized technique that I think it's neat, but it's not very practical for everybody else. So what I want to do is try to develop a quick method, a cheap and quick method to screen for organic fluorine. And the way my approach to that is what I would like to do is heat the sample up to a very high temperature, 1300 degrees C, and convert all the different forms into one surrogate that we can readily measure. And tetrafluoroethylene is what I'm focused on right now. And this is just an experiment from last year where I looked at some different PFASs and I heated them up to real hot temperatures, and you could see instrumental response for this compound tetrafluoroethylene. In fact, I can measure it within 2.5 minutes. This is a time scale on the bottom here. So this is great. This is encouraging that maybe I'm on to something of a quick and cheap way to measure these things. And then I have to show that I can somewhat quantify. So what I've done here is I've made up some different concentrations of perfluorooctanosulfonic acid, PFOS, and I can show that as I increase that concentration, my instrument response increases. So this is good. I could potentially somewhat quantify. And then this final example of some proof of concept experiments is here. I took some activated carbon. I ran it beforehand. That's the top one. On the bottom, I exposed it to PFOA, and then I ran it again, and I can actually detect the PFOA on the carbon. And there's no sample prep. I just take the sample straight as such, stick it in the instrument, heat it up, I get a response. So it would be fast. It would be hopefully cheap. I'd like to get it down to like $50, $20 a sample. And then I'd like to employ it as a screening method because I believe municipalities really, really need this, as well as other researchers. So having said that, I appreciate your attention, and I'm more than willing to open it up for questions.
So again, if you have any questions, if you want to type them into the Q&A box, then I can read them off for John.
Uh-oh, no questions.
So I had one, John. So you talked about the different sort of regulatory approaches on that. And it seems like, there's definitely a challenge in, like you said, putting these regulations out there. Then what are treatment plants supposed to do with that? Yeah. And that seems like a really, obviously that's the most expensive way to deal with it versus, like you said, reducing where these things are coming from. So that definitely seems to to be the direction we need to go in. So I have two questions that came up. One is, how do you destroy the stuff?
Boy, there is ways to destroy it, but not economically. So that is yeah, you could talk a whole talk about remediation. People use plasma, people use high temperature. If you incinerate it, you have to worry about, the co-contaminants and, what is the byproducts of that. So, I mean, there are ways to destroy it, but the question is, how do we do it cost effectively? We need to find a cheap way to do it that doesn't have high environmental impact. Now, the other thing I want to talk about for destruction is it doesn't make sense to treat it right in the water, because these things are present at part per trillion, very, very low levels. So it seems to me like the best approach would be first concentrate it, absorb it from the water, and then take that sorbent and then treat it. So that would, in my opinion, and that's how most people are doing it right now. In fact, the military, I think, is using granulated activated carbon and then incinerating it afterwards. So, but yeah, that's a great question. There's a lot of people working on how to destroy it in a cost-effective manner. It's not my area, though. Remediation is really not my area.
And I guess along those same lines, I mean, what are they looking at as far as treatment, like wastewater treatment plants, and what they can do to remove? I mean, is there any? I assume there's work being done on it sort of at that level, but maybe it's that, like you said, concentrating it.
Yes, that's what I believe. I don't know of any wastewater treatment plants that are targeting PFAS. I know they're interested in it, but I would think that the logical place to start is activated carbon or ion exchange resin, because that's what we know the best, and that's what the military is using in a lot of their treatments of their sites that they're working on right now. That would be my guess where they would start. But like I said, these things, I can see that carbon and that resin getting consumed so quick because there's just so much other stuff in there, that much higher concentrations like dissolved organic matter and so on, that would really foul these sorbents very quickly. Yeah, the problem is they're just such low level concentrations that we're dealing with. And back to the regulation thing too, I think it's really crazy if you look at the differences in all the states at what levels they're proposing. It's like, where are they coming up with these numbers? Because the science really hasn't caught up yet to determine what concentrations, are these things really a health concern? So, yeah, I don't know.
Yeah, that's where it definitely seems that some of this gets to be very political.
Yes.
Without waiting for the science to catch up. And it's, to a certain degree understandable. People are concerned about public health and want to be seen as doing something. But in this case, jumping the gun on some of this, it's going to make it really challenging to address.
Yeah, absolutely. And I see there's another question about how the treatment plants remove. I think I kind of pretty much covered that. But remember, if it doesn't end up in the effluent, PFAS is going to end up in the biosolids. And I think the biosolids are actually more concentrated than the effluent, at least from what I've seen. So that's why I'm very interested in the biosolids. So, and even if, a wastewater treatment plant used sorbent, then what happens to the sorbent? If it gets landfilled, then it goes to the leachate, and then the leachate comes back to the wastewater treatment plant. And once again, you got this cycle going on. So hopefully I've addressed that question too for Albert.
And then there was one that came up in the chat, and it was just kind of a question about what bioaccumulative means again, which I think you kind of had a picture of that, but
yeah,
if you want to go ahead.
Yeah, you have to be careful. I fall in that trap too, that you have to be careful of bioaccumulation, bioconcentration. They're all, people use them interchangeably, but really you have to be careful. So I will go back to my slide, and bioaccumulation is the ability to accumulate a substance in the tissue of a living organism. So how well does it move from the environment to an organism? Wow, the ability to concentrate something in tissue successively higher in the food chains. That's biomagnification. There's a problem with my slide. It should say bioaccumulation and biomagnification. I'll fix that. But anyhow, yeah, if you go back to that slide, it has the definitions right there. Unless
there's any other questions out there for John, we're gonna let him go and get back to the lab and continue on with the.
Yeah.
the
And if you
work
think
he's
of
doing.
anything else, just feel free to shoot me an email.
Yeah, and I think we probably will take you up on your offer about the plastics, where microplastics,
Oh,
definitely
yeah.
another topic of interest, but we'll get back in contact with you about that at a later point.
All right. Well, thank you all for your attention and have a good day.
Thank you very much, John. All right. Go back. All right, so again, there was John's contact information. If you have questions for him, or if you want to route stuff back through me, I'd be happy to pass information on. So moving on, we had asked for some updates on the, I guess maybe I'll take a step back for a moment here. When Allison and Keith and I went down to talk with Illinois EPA back in February, Sanjay brought up the whole idea about PFAS and the concerns that are out there surrounding PFAS, and the fact that they were going to be starting on a sampling project. And so he really kind of impressed upon us that we should really start talking about PFAS. And so that was kind of where I'd done a presentation, I think back at our, I guess that would have been our March meeting, and then bringing John in and trying to get some information from Illinois EPA on their sampling project. We had anticipated having Rick Cobb from the drinking water group at Illinois EPA to be able to present at today's meeting, but he had a conflict on his calendar. So he provided me with some information. Some of it kind of covered things that John already covered for us. So I tried to just boil it down to really focus on what Illinois EPA is going to be doing. So they had gotten some grant funds from US EPA to do sampling, and along with some of their own funds. And so they're going to be looking at sampling all the active entry points to community water supplies in Illinois. So there's 1,455 active entry points, which cover 1,749 community water supplies. And so if they, as they go out and do the sampling, as they get their results back, if they get detections at or above the minimum reporting level, which is quite low, I think I have it on another slide, then they will go back out and do follow-up sampling as soon as possible. Let's see. So they're estimating that they could do up to 5,000 samples, depending on what they see. So, they're really looking at trying to be responsive to any positive samples that come back, be able to go out and continue to do sampling to really get a handle on what those numbers look like. They're going to be working with a lab out of, I believe it's Northwest Indiana, to analyze these. They'll be using the US EPA methods. They will be looking at 18 different PFAS. These are, like John said, there's over 4,000 of them out there. They're looking at 18 that are used. Actually, they're no longer being used, but they're out there in the environment and will be with us for a long time. So their minimum reporting limits are 2 to 14 parts per trillion. So if they have anything that is shown above those reporting limits, they will go back and do additional sampling. They're planning on getting their sampling started in August, and they anticipate it'll take a year to complete. The protocols for doing this sampling are very specific. Just looking at the list of items that John talked about that contain these types of chemicals, you need to make sure as a sampler that you don't have any of those things on you. So, I was looking through their sampling procedures, and, no sunscreen, no bug spray, make sure that, your rain gear is doesn't contain any PFAS. You're not wearing any Gore-Tex shoes, looking at the sampling equipment that you have. So, it is very specific and rigorous on the QA side. So it is definitely just going to take them a chunk of time to get this work done. They will be making the results available through the Drinking Water Watch website. And there's also a PFAS investigation network interactive dashboard, which I have a picture of here that Rick sent me. So these are the way that they're going to share information. You can also see on this, I believe, where they'll be sampling, kind of what that network looks like across the state. So that information will be available as they get it back from the lab and get it through their QA system. These, for any of you really interested in the chemistry side of it, these are the compounds, the specific compounds that they will be looking at. And part of the project is to obviously identify things within the state, and but the data will be a part of a national database, the science on this topic. And then, as John had mentioned about the bill that is out there right now, these are the numbers that they're looking at. And again, these are really low numbers. The nanograms per liter. So that was the parts per billion. No, parts per trillion. Sorry. So these are very, very small numbers that they're looking at. And again, like John mentioned, and I think we've talked about before, nobody knows how to get to these numbers. So it is definitely going to be a challenge with numbers like this going forward, because the science just isn't there yet as to how to get there. All right, so we are, okay, let's see. I'm going to bring Leah in on this. So if you have any questions about the PFAS stuff, please feel free to send them in to me or to contact John directly. And we'll see what we can do about getting answers. And we will get this presentation up on the website. And I know back in March timeframe, Leah had added another tab to our outreach or resources list that really kind of just pulled together some different resources that are available out there on the web around PFAS. It's definitely a topic that we will continue to be talking about into the future. So Leah, if you want to unmute and you can take on this next part of the presentation.
Okay, can you hear me?
Yeah.
So if you are looking for those PFAS materials, they are under that members tab that's shown right here, except this is an older screenshot, but you could find it in that section. And I just wanted to give you a quick update of our outreach materials. So I create education outreach materials for you, our members, to meet the education outreach requirements of the MS4 requirements. So all our summer materials are available, and then currently working on fall, so just to look ahead for those. Next slide. And I think these slides just kind of show you where you can find it. So if you, under members, in the campaigns, you click on summer or fall, or the other topics are there too. For summer 2020, we have some new articles. The topics are here. One, maintaining your lawn to protect rivers and streams, which talks about basically fertilizer use and stormwater runoff, how that brings that into our local rivers and streams. And then we have a couple articles about kind of focusing on mosquitoes and more the ecology of watersheds. So we're starting to bring in some of those materials now too. And then healthy rivers and streams have more than just clean water, telling people what makes a healthy stream, and that it's not just water chemistry, but we have to look at the habitat there and what is actually living in our rivers and streams. And then we have one topic about dams as well. So we're starting to kind of branch out and bring more topics into our education and outreach materials. Next slide. And here's a look at some of them. So we have social media posts that correspond to each blog topic. So you can see some of them about lawn fertilizers, a little bit about ecology, and a few about dam removal. And then I've also created a handout about just kind of generally about stormwater runoff, because that's where a lot of how pollutants enter our rivers and streams. So it's really good to share with residents to kind of, fill them in on stormwater runoff generally. And then we have our past material. So last year, all of our blog posts, graphics, and we had a handout too, were about stormwater detention basins. And those are still great resources that can be used again. And then looking ahead to fall, our fall campaign centers around leaf litter. And so last year we created this poster on the right, and we'll be creating more resources, going into more detail about how to use leaves and other resources too. If you have something that if you are looking to talk to your residents in a specific way about fall and leaf litter, you can let me know, because we're still making these resources. So now would be a really good time if you had something specific in mind that we could create for you. And I think maybe on the next slide, so it's really one way to share these materials is through social media, and you can follow the Lower Des Plaines Watershed group as just a way to stay connected and also see examples of how we're sharing the resources that we've created. So on the next slide, just here's an example of how you might use some of these resources. You could share the graphic and then also link to one of the blog posts is how this is used right here. And then Jennifer, do we have polls for these?
Yes, so I'm going to launch some polls. So we've been trying to get feedback from all of our members because we are doing these things for you to use them, and we would like to know how you're using them and if there are things that we can do. So I'm going to go ahead and launch some polls, some questions, and if you could go through and answer these for your organization, although this says community, really for your organization, because we do have members who are not necessarily communities, and we're happy to develop or customize things for any of our members. And so if there are ideas, please get back to us. Always feel free to contact Leah or myself if there's something that you want to get either customized, if you have a particular topic that would be really helpful. And again, this is all tied one way or another to water quality. So if there are things that we can assist with, we are here and happy to help out on that. Let this just go for another 15 seconds. And so I have a number of folks who have answered yes to, are you interested in customized outreach materials for your communities? So I can't necessarily see who you are, but please do reach out to Leah or I. You can stick something in the chat right now if you would like to just, who you are as far as requesting for your community, and we can follow up with you, or you can follow up directly with Leah on that, because we are happy to take whether it's taking the social media posts and adding your logo to them, or a specific message coming from your community, and we can work through that with you. All right. Thank you very much. So
And
then there's Leah's.
Yeah. So just to reiterate, please reach out, and especially those who would be interested in some customized materials, you can let me know. Or if you have any additional feedback about what topics you'd want to see related to water quality or different kinds of materials that you might be interested in.
Thank you. So I'm just going to give a quick update on where things are at with our bioassessment for this year. We have about 40 sites that we are going to be getting out to across Hickory Creek, including Spring Creek and all of the other tributaries to Hickory Creek. That sampling, it's a combination of work being done by our lab microbac, who will be collecting the water chemistry samples, and working with Midwest Biodiversity Institute to do the habitat assessments, the macroinvertebrate sampling, the electrofishing, and we'll be out there as staff collecting our sediment samples, getting those to the lab, and then Midwest Biodiversity Institute will be putting together the overall assessment and report. And so we have so chemistry work got started in late May. Midwest Biodiversity Institute, they're out here. They just arrived in town this week. So the work that they're started on some resampling that we're doing on the Des Plaines River. Last year, because of all the high water levels, it was just not safe to be out on the river. So we weren't able to complete the sampling that was on the main stem. We were able to complete the smaller tribs that we did last year, but not on the main stem. So we're utilizing what was left in our budget to do some resampling on a subset of those stations. So they're getting started with that. And then they're going to jump into the Hickory Creek sampling as they go along. We're also doing some expanded dissolved oxygen monitoring, which we're looking to get started next week. We're actually going to get out tomorrow and deploy several of our probes, and we're working in partnership with DRSCW. So we're borrowing some of their probes to be able to get this done in as timely manner as we can. Sampling itself lasts for about a week at each site, but because it's very weather dependent, we're really looking at kind of some of the worst case conditions as far as dissolved oxygen goes. So this hot weather, but with no rain. So we're really looking for those low flow conditions. So we're going to get probes set out. We'll be collecting some additional water chemistry, doing chlorophyll A sampling, both in the water column as well as on substrates, on things like rocks. But to really get a better understanding of how nutrients may or may not be impacting our stream systems. So those things will, like I said, be getting started next week. We will also be doing some fecal coliform sampling. It needs to be done within the May to October time range. So we need to get this dissolved oxygen sampling done first while the weather is really hot. And then as soon as that's done, we will jump into the fecal coliform sampling. And it's a little more than just visiting 10 sites. Those samples you need 5 samples from each site within a 30-day period. So we'll have 7 sites within the Hickory Creek watershed, and we're doing 3 on the Des Plaines. So we will get those done. Our target's to get those done by the end of September. And then we'll be out collecting sediment in September, October to complete that part, which will include both sediment on the Des Plaines sites, the resampling sites, as well as a subset of sites on Hickory Creek. So far everything is moving along well, pretty much as can be expected. We were really a little concerned about how things were going to work in light of COVID, but so far it looks like we're able to move forward with our sampling as planned. And then not a whole lot to say on the chloride time-limited water quality standard for chlorides, the chloride variants. The hearings, public hearings that were done in February, the deadline has been moved a few times as far as submitting briefs. But I think in the end, I think that the time is being very well used as far as the petitioners working with Illinois EPA, US EPA, and others that had submitted comments and testimony to really resolve the issues that are out there, and be able to kind of figure out how to move forward with this. So, kind of much rather see waiting a little bit longer to get these things in if we're going to end up with a better product in the end that everybody can at least live with. So at that point, there's hopefully we'll hear some things as we get towards the end of August and have something to report back at our September meeting as far as where things are going with the chloride variants. And again, we mentioned this back in May in light of the current situation of really not wanting to get a bunch of people together in person. We are looking at how we're going to do our winter de-icing trainings this fall in a virtual format. So we're working that out with Fortin Consulting and kind of working through what some of those details look like. So more information to be shared. Not sure if we're going to end up sticking with the original dates that we had identified. It really kind of depends on exactly how things work with Fortin and how their setup looks. We're going to see some of that. They're doing a SALT symposium at the beginning of August that several staff from here are going to be participating in. So I think that'll give us a pretty good taste as to how their technology is working on this, and we'll be able to move forward with some better decisions at that point. I've just sort of always included the list of members that are part of the water quality, the chloride variants. So we have a list of current members that are petitioners as part of that, and then a list of potential other members that once the variants would go into place and require petitioners to participate in a watershed group focused on the chloride issues. There's a number of other members that we may end up gaining participation from. So before we close out the meeting, I don't know if there's, Allison, you are able to share anything if you would like, if you just unmute. But if anybody has any questions, we will be at this point still, I think, planning to hold our September meeting via Zoom. As in some respects, I think we've had some really great participation via Zoom, especially for those that are a little bit further away from our normal meeting place in Romeoville. But I think at this point, we'll still be planning on a Zoom meeting in September. So if there are any other questions. All right. There you go. Well, thank you for joining us today. Again, please do follow up with Leah or I with any questions around the education and outreach materials, any questions you want me to forward on to John around the PFAS stuff. I think we'll definitely take him up on his offer to talk about microplastics, as that is definitely another area, the emerging contaminants that I think would be great to get some more information on. All right, well, I see no other questions, so thank you again for your time, and we're going to go ahead and end the meeting. Stay safe and enjoy the rest of this hot weather this week.